Hello friends, addressing modes is one of the most easiest topic in your COA. But if I ask you to find out the effective address from any instruction where I tell you the addressing mode which is used, may be confusing for you. It may be very confusing for you to determine the effective address correctly. In this video, we'll discuss about all the major types of addressing modes and how to find out the effective address. Effective address is nothing but the actual source address of the data. We'll see how to find out the effective address for all the different types of addressing modes in this video. Let's start the discussion about different types of addressing modes. I will start a simple topic which talk about different types of instructions based on the number of addresses it supports. Means whenever we write some instruction, it may be anything, load, move, store, whatever. Whenever we write some instruction, there are some memory locations or memory addresses we write along with the instructions, right? Do you agree with me? Yes, we write like that. For example, if I write load R0, R1, what is this R0 and what is this R1? This R0 is nothing but some register, address of some register, right? General purpose register. What is R1? R1 is also nothing but some address. What type of address? Some register address. If we go to R1, then only we'll get the data, right? R1 is not the actual data. R1 is the address of the actual data, where the actual data is present, right? These addresses, maybe we can use these addresses as our general purpose registers or from main memory location also. If I write store R0, location A, that means what I am doing? I am moving from R0 to location A. What is location A here? Location A is nothing but the memory address where I am going to store the data. And what is R0 or R1? The general purpose registers address, right? So every time whenever we write some instructions, we deal with some addresses basically. It may be from registers or from main memory locations. Now, based on the number of addresses your instruction supports, we have some different types of instructions. We can divide our instructions into multiple types. What are those? Number one, 3 address instructions. Now, from the name, you can easily understand what it is. It says the instructions that can hold up to 3 different addresses. The addresses can be general purpose register address or your main memory location or main memory addresses, right? Can you give some example for this? Yes, we can. For example, add R2, R3, R4. So here total how many addresses I am using in this instruction? 3. This one and this one. Although I am using all register addresses, you can use memory locations also, right? What does it mean? Add R2, R3, R4. This is nothing but R2 equals to R3 plus R4. Fine. Then we have the second type of instructions, which is 2 address instructions. Now from the name you can easily understand, this type of instructions can hold up to 2 different addresses. It may be register or memory location. For example, add R2, R3. So how many different addresses I am using in this instruction? Only 2, right? Now what does it mean? This means R2 equals to R2 plus R3. Fine. Next is 1 address instructions, which is interesting, right? Till now we have dealt with either 3 address instructions or 2 address instructions. Now how to deal with 1 address instruction and how to write it? So in one address instruction, we write or we deal with only 1 address. This type of instructions can hold maximum 1 address. How to write it? See here, load LOC we have written here. What is this LOC? Some random memory addresses I have taken. This LOC is some memory address. You can take register also. What I'm doing, load LOC. I'm loading something from where? From this location LOC. I don't know this address, any address from my main memory. Now, if you see the previous examples, previous instructions, we know where to store, right? Here I am storing to R2, here also I am storing to R2. But here I don't know where to store, right? Now you have to remember one thing. In 1 address instructions, we don't have the destination mentioned in the instruction. By default, the destination of this instruction is the accumulator. What is accumulator? Accumulator is nothing but a special register that can hold some data temporarily. So I am writing load location. It means your compiler will understand that I have to load something from this particular memory location and I have to store this to accumulator, a register. This accumulator is totally used to store the data whenever we use one address instructions as like that. So no need to mention where to store. I know the location. By default it's accumulated. Fine. So we have interestingly one more type of address instructions, which is zero address instructions. Now one address instruction is fine, we understood. What about zero address instruction? We don't have any address only here. Yes, we have zero address instructions also, means no address is mentioned in the instructions. How to write it? Push and pop. If I write push, I know what to do, right? If I write push, means I am loading something to where? Some memory stack. There will be some stack where I will just push it. If I write pop, I know the topmost element will be eliminated. Push means I will add to the topmost position. Pop means I'll eliminate from the topmost position, right? We know this. So these are the different types of instructions based on number of addresses it supports. Fine, I hope it's clear. Now we'll start the actual topic of discussion, which is different types of addressing modes. This is the actual topic. We'll start now. Now, if you see various tutorials, YouTube videos or some other articles, you will find lots of addressing modes are there. Yes, we have many addressing modes, but in this video we'll discuss only some of the most important addressing modes. Don't think that that's it, we don't have any other. Yes, we have, but these are the most important addressing modes we have. Fine. So before we'll discuss all these addressing modes one by one. Before that, let's see what are the addressing modes which are supported by RISC type of system or RISC computer. So basically there are six major addressing modes which are supported by RISC. We have some other also, but these are the most important addressing modes which are supported by RISC. What are those? Immediate addressing modes, register addressing mode, absolute addressing mode, register indirect addressing mode, index addressing mode, and base with index addressing mode. We'll discuss all these addressing modes one by one. Now, one important question you may get in competitive exams or maybe in your academic exams, you will find they will write in question, you will get some instructions, they will mention the addressing modes, then they will ask you to find out the effective address from the instructions. So to know how to find out effective addresses from all different types of addressing modes is very important. What is immediate addressing modes and all other addressing modes is very easy to understand, it's theory. But to know how to find out effective address is very important. You have to know that. So we'll discuss one by one how to find out effective address also. Fine. Effective address means from the instructions, you have to understand that if you want the data, where you have to go, where is the actual data located in. So that address is nothing but effective address. Fine. So the first type of addressing mode that is supported in RISC very widely is your immediate addressing mode. So in immediate addressing mode, what we do is we explicitly forward the operand with the value. Whenever you want to add something, say I want to add 200, 250 or 500 with some other value which is already there in some other register, I can directly pass this value 200. No need to store this value to some register and I will ask to add with that register. You understood that, right? Suppose I want to add 200 with something which is there in R6. Suppose in R6 we have already 200 or 250 and I want to add 200 more with this. I have two ways. One way is I will first store this 200 to some register, then I will write, say register R5 equals to 200 I will write first, then I will do add R4, R6, R5. We can do that, but in immediate addressing modes, no need to store this data wherever it's constant to any other registers. You can directly pass it. But you have to use this hash symbol. If you are getting hash symbols, you have to understand that this is not an address now. R4, R6 are the addresses of some registers, but this is not, don't be confused. Many students think that it's 200 means 200 is the memory location. No, This is not the memory location. But how you will know that this is not memory location? By seeing this hash symbol. If there is a hash symbol, you have to know that this is a constant value, not a memory location. Means we are dealing with a constant value. You understood that? So the next type of addressing mode, here in immediate addressing mode, we don't need any effective address because the value I am directly passing, right? I am not searching the value anywhere in memory or register. So in immediate mode, nobody will ask you to find out the effective address. They ask you from the next addresses. The next type of address is register mode. So in register mode, we deal with only registers. Means whatever operation you want to perform, you have to perform through some registers. You cannot directly use the data. If you want to use add this 200 first, you have to load it to some register, then you can add it. You can add two registers. You understood that, right? You directly cannot pass the value. So see this example, load R4 comma R2 means R4 equals to R4 plus R2. Now if I ask you from this question, register mode is very clear for you, I guess. Now if I ask you what is the effective address of this instruction, from this instruction can you tell me what is the effective address? Yes, the effective address in register mode is nothing but the source address from where you will get the data. What is the source address here? R2. So from R2 only you will get the data, right? And then you will add to R4. So effective address is R2 here. So next type of addressing mode is absolute mode. In absolute mode, we deal with memory now. The effective address will be memory, not register. In register mode, the effective address is register, some other register. But in absolute mode, it's a memory location now. See what I'm doing, load R2 comma num1. This num1 is nothing but a memory location. You can write LOCA, whatever you want. You can write simply A also. So now the effective address is this memory location num1. You understood that, right? In absolute mode, the effective address is the memory location. Means we are getting something from memory location. In register mode, we are getting something from other register. In immediate mode, we are getting directly something. Understood that? Next type of very important addressing mode is indirect mode. So name itself says indirect, means directly you won't get the data or directly you won't get the address. What you have to do is, see this example, then you will understand. I have written what, load R2 comma in bracket R5. So if I write R2 comma R5, we know very well what it is, but see the bracket. If I am using bracket, you have to understand that this is indirect mode. So what does it mean? Means I have to get some data. From where I will get the data? I will go to R5. If there is no bracket, then I will go to R5 and I will get the data, right? We know that R5 will be the source of the data. But here, since we have the bracket, if you go to R5, you won't get the data directly. Understand that? You go to R5, you will get some, when you go to R5, then you will get the actual address of the source. You understood that? You are in R5. In previous case, if you write R2 comma R5 means R5 is holding the actual data. But if you write this bracket and using indirect mode means R5 is holding address of the actual data. You will get the address of the actual data. Then you have to go to that particular address and you will get the data. This is how indirect mode works, right? Is that fine? So any example can you give when we use indirect mode? Yes, pointer, the concept of pointer, where indirect addressing mode is used, right? So in pointer, what we do? We write a star symbol B. That means this B is holding the address of the actual variable, right? Then we have to go to that actual variable and we will get the data. So pointer and all, I think it's nothing new for you. So you know very well, I don't want to waste your time on pointers. So next type of addressing mode we have is index mode. This is also a very important addressing mode, index mode. So in index mode, what we do? Index mode is very useful whenever you deal with some arrays. So what do we do in array? Consider I have an array where I have 5 different data. It may be anything, maybe 5 different characters I have stored in an array. So we know the starting address will be what? 0, then 1, 2, 3, 4. Right? If you go to 4, I will get the last character. If I go to 0th position, then we'll get the first element from the array. Right? We know that. We go one by one. Fine. Now, index mode says whenever you know the starting position of the array, you know the starting address where it is started. And if you know how many times you have to jump, then you will get the data directly. You understood my point? Suppose out of these 5 elements, you want to access third element. Please listen carefully. You have 5 elements and you want to get the third element. Third element means 0, 1, 2. So in array, it will be in second position, right? You want to get this position. Now, how can you reach this position? If you know the starting position, it may be anywhere, maybe 1000, the starting address is 1000, next is 1001, 2, 3, 4, like that it's going. If you know the starting position and if you know how many times you have to jump, then directly you will get the data. If you know the starting position, which is 1000, and if you know that I need the third data, then you will do what? 1000 plus 2, right? You will get the data. So this is how index mode works. You will have the effective address will be calculating like this. X is nothing but the jump, whatever I said, how many times you have to jump or which character you want, fourth character, third character. This is offset X, and plus this Ri, I am writing in square bracket here, right? That means this Ri is a special type of register where the base address of the array is stored. If I go to this particular location Ri, I will get the starting address of the array. If I take X, means I know how many times I need to jump, then easily I can get the data by getting the starting address and the jump, how many times I need, or offset. Fine. So this is how it works. We have an pictorial example also, see. So this is how it works. Suppose I want this data which is present in 1020 location in my main memory. I know the starting address which is 1000. So from here to here I have a program or I have a set of instructions. I need to get this particular instruction. Suppose I know the starting address which is 1000. This 1000 will be not directly given in index mode. It will be given inside a register. So in R5 you will get the starting address which is 1000. Now which element you need? This one. Where you will get? By taking this offset. What is the offset? 20. So if it is 20, that means the address which is given in R5 plus the offset 20, 1020. Go to location 1020, you will get the data. Fine. I hope it's clear for you. So we have two different types of variations in indexing mode again. So first one is base with index. So it's written like this in bracket Ri, Rj. So here what you will get is it will be given as this Ri will contain the offset and this Rj will contain the first address of the data. Fine, similar thing, but here this Ri will be not directly given, it will be stored in some other register. It also possible. The offset you are storing in Ri and the initial position you are storing in Rj. Now base with index plus constant. So here in some cases we have some constant value also to be added with offset plus the actual address. This is how you can get that thing. Fine. So finally the table in front of you, it will be very easy for you to understand now what it is. We have all the different types of addressing modes. This side I have the assembly syntax, how we write, and this side we have how to find out the effective address. For immediate, I told you nowhere to go. The value itself is the operand, so no need to find the effective address. For register, I will get to the source register Ri. To absolute mode, I will go to the memory location to get the effective address. For register indirect, what I will do? I will go to the location which is mentioned inside Ri. Ri is not the direct address, but inside Ri we have the actual address. Index, the offset plus the first address. Base with index, the offset which is stored in some other register, and the first address which is also stored in some other register. Fine. Now these are the basic addressing modes which are supported in RISC. In CISC, all these types of addressing modes are supported by default anyways, and additionally we have some more addressing modes which are specifically supported in CISC type of system, not in RISC. First is auto incremented mode is supported in CISC. See how to write it? Ri plus. So if I write it, you have to understand that this is auto increment. I hope you know what is your auto increment. You already have gone through in C language, right? So auto increment means if I write a plus means a equals to a plus 1. You know that, right? The next increment. So this r bracket plus is nothing but same thing. Ri equals to ri plus, it may be 1, 2, 4. It depends on the length of the instructions, right? If it is 4 byte length, then the next address will be ri plus 4. We know that, right? But one thing you have to understand, or you have to note from here. If I say that my ri, the value of ri is 1000, or ri is holding the memory address or register address of 1000. If I write ri plus, what will be the effective address? Now without doing, if I am not doing any operation, it will be 1000 only. Ri plus means initially I am not incrementing. I will perform the operation first, then I will increment. It's not pre-incremented, it is post-incremented. See the plus symbol. Plus symbol is right hand side, not left hand side. Means first do the operation, then increment the value. So since I am not doing any operation, if I ask you what is the effective address, the ri itself is the effective address. But once you do something, after that it will become ri plus the offset, or how many times it will be incrementing. It depends on the instruction size, right? Next is auto decrement mode. So auto decrement means it will be decremented by the size of the instructions. If it is 1 byte, 2 byte, 3 byte, 4 byte, it depends on the application, right? Now there is a difference in auto increment and auto decrement, you have to note. Auto decrement also I think you have already gone through in C language, right? If you see here, this is post incremented, right? Right hand side I am writing plus. If you see here, left hand side I have written minus. Means it will be decremented first, then operation. Here operation first, then incremented. There is a huge difference on that. Now if suppose ri is holding 1000, if I ask you what is the effective address here, where I am writing minus in bracket ri, then it's not 1000, it's 1000 minus, it depends. If I am using 4 byte addressing modes, then it will be 1000 minus 4, so it will be 996. But in this case it's 1000 only. Here decrement is decrement, you have to do decrement first, then operation. Here operation first, then decrement. I hope it's clear. So apart from these two modes, I have one more mode in CISC. We have one more mode in CISC, which is relative mode. Relative mode is almost similar with your index mode, which we have seen in array, right? Exactly same thing I will say. The only difference is in array or index mode, what we did, the offset is given as x, a constant jump, right? And the effective and the address where the actual data is present, or the source address, was stored inside a general purpose register, R0, R1, R2, wherever it is, RI, right? We have done like this in indexing mode. In relative mode, same operation I am doing, but what I am doing, instead of wasting a register, general purpose register, the next address is stored inside the special purpose register called PC. Now what is PC? I have already discussed in my video number 2. PC is a special purpose register, right? That can hold the address of the next instructions to be executed. So what we can do, we can take that advantage. Instead of using a register, I will ask my PC to hold the base address, which can be 1000, 2000, whatever. Then I will give the offset value as x. And then I will tell you, find out the effective address. It will be x plus whatever they are inside PC. It may be 1000, 2000, whatever. Fine. So I hope all these addressing modes are clear for you. That's it for the video. We'll discuss some more topic in the next video. Thank you everyone for watching my video.